Hello, my name is Kevin Yu. My student number is 400458686, and today I want to explain why quadratic probing and double hashing have a runtime of theta 1. So in this first example, I have a hash table size of 7, and I want to insert keys 3, 10, 17, and 24. So I have this equation where every time there's a collision occurring, I increment I by 1, and hopefully we can find a new place to insert our key. So as you can see, 3, 10, 17, 24, mod 7, all end up at 3. So for key 10, if there's a collision at index 3, we increment I by 1, as you can see, and we can insert it into index 4. For key 17, we can insert into index 0 after incrementing I again. And then for key 24, we increment I again, 3 to the 2 now, and we can insert into index 5. And doing these calculations will give us a runtime of theta 1 or constant runtime. For double hashing, it works similar so that whenever you have a collision again, you plug your key into your secondary function, and that will tell you how much to shift it by to the right. So in this example, when I try to insert 10, it's occupied by 3. So I plug it into the secondary equation, and I get 2. So I shift 2 from index 3. Same for 17. I get 1, so I shift 1 from index 3. And for key 24, I shift 3 from index 3. And again, doing these calculations will give us a constant runtime of theta 1. Now, finally, for question 2, explain why m is defaulted at 37. 37 is a prime number, so it will give us less collisions compared to non-prime numbers. As a counterexample, I have m equals to 6, which is not a prime number. In fact, 2 and 3, 2 times 3 is 6, so there's many multiples for 6. And in this example, I try to do in my primary equation, I want to insert 3, 9, 15, and 21, and they all give us 3. So they're going to be multiple collisions. So we plug it into the secondary equation, and we get a lot of zeros. So what does that mean? It means that it will try to insert 9, but it can't. It'll try to insert 15, but it can't, because it's all occupied by 3. And this is a huge issue, and it's primarily the reason why we use prime numbers such as 7 and 37. As you can see, it works out when m is 7 here.